So now we're going to look at the pH scale. And the pH scale is just another way to measure the concentration of hydronium ions that are in solution. From that, we can also measure hydroxide ions, but the pH is just another way of directly measuring that concentration of hydronium ions. So here is the PhET simulation that we've looked at before, and this is looking at an acid. So we have a strong acid, and we are combining it with water so that the acid dissociates into its conjugate base and a hydronium ion, and we know that we can calculate the concentration of that conjugate base or the hydronium ion if we know this concentration using the pH meter. So this is a probe, it's an external tool that you can place into solution, and it calculates the concentration of the hydronium ion. So it is able to do the calculations to give us this pH scale, and the pH scale is just a little bit more of a common use outside of the chemistry realm. Of course, in chemistry, we've been using the molarity, but the pH is just more of a universal measurement that can be used. And again, you're able to just place that probe right into the solution to get this measurement. So the main pH calculations that we will be looking at is looking at the opposite log of the hydronium concentration, and pH plus POH is equal to 14. And we'll be using this one in the next equation. But if you know this one and this one, we can get to any of the others. So let's do an example here. What is the pH of the hydronium concentration in a vinegar solution that is 0.11 molarity? So I know that my hydronium concentration, vinegar is an acid, that my hydronium concentration is 0.001 molarity. So I'm just going to write down pH is equal to the opposite log of 0.001 molarity. And actually, the brackets actually symbolize concentration, so I don't need a unit right there. And if I plug this into my calculator, the log of 0.001 is -3. So the opposite of -3 would give us a pH of 3. And pH is a scale that is 0 to 14. So a pH of 3 means that it is very acidic. And I'm going to show you how to do this on your calculator here. All right. So this is a scientific calculator that is in the resources on the main page of our Canvas page. So all we need to do, I don't have the ability to do the opposite of log. So what I'm going to do is log, and we can see here that it automatically puts in that parenthesis. So I'm going to do the log of 0.001. and then put it in parentheses and hit equals, and it tells me that it's -3. So then if I know that it is -3, I need the opposite, or the negative log of that. So the 2 negatives equals a positive, right? Or the opposite of -3 is equal to +3. Now, I know that many of you have different calculators. What I would suggest is looking on YouTube. That's where I found the best way to, like, if you have a TI-83, you can go to YouTube and type in how to do logs with the TI-83. And it will show you, there will be videos to show you how to get that answer if you're not getting -3, or if you typed it in on your graphing calculator and you typed in negative log of 0.001 and you did not get 3, then we need to figure out what's going on. Now to find the POH, all we need to do then, if we know the pH, is to use this guy. And if we know that pH plus POH equal to 14, I would say, well, 3 plus what is equal to 14? So we would figure out, and then we would subtract 3 from both sides. So the POH would be 11. So again, we were given the hydronium concentration, so we know our H3O plus concentration was 0.001 molarity. So with that, we were able to use this calculation to start the opposite log of 0.001 to get the opposite of -3 to get a pH of 3, and then to find the POH, we would plug it into this guy. If we know the pH, we know that pH plus POH is equal to 14. Let's look at this example. Water self-ionizes according to the following equation. The concentration of hydronium in pure water is, so I know that H3O plus, it just said the concentration of the hydronium is 1 times 10 to the -7th moles per liter, which is capital M for molarity. What is the pH of water? So we're going to look back here. If I know the concentration of my hydronium, I can find the pH of water by just doing the pH is equal to the opposite log of 1 times 10 to the -7th. And again, brackets symbolizes concentration. So the pH, if you plug this into your calculator, you should get 7. And again, so the POH, I'm going to use that same equation before, knowing that pH plus POH is equal to 14. So if my pH is 7, 7 plus what is 14? So we know our POH is also 7. So pH of water we know is neutral, so our POH must also be 7. Let's look at the next example, looking at the pH of blood. So we're given our hydronium concentration as 4.8 times 10 to the -8 moles per liter. So let's plug in using the same equation up here. So pH is equal to the opposite log of 4.8 times 10 to the -8. And if you typed it in correctly, you would get -7.32. So the opposite of -7.32, so pH would be 7.32. So pH is slightly basic. Remember, 0 is really acidic and 14 is really basic. So to find the POH, remember pH plus POH is equal to 14. So to find POH, we would need to take my 14 and subtract pH. So 14 minus 7.32 would give me a pH that is 6.68, pOH. Now let's look at your calculator. I'm putting this into your calculator to make sure, because this is where a lot of people go wrong and get the wrong answer here. All right, so let's make sure that you are typing this in. I'm going to use the log of 4.8. Now remember, to do the exponent, we're going to do exp down here. And that puts in the 4.8 times 10 to the, and I'm just going to do a negative 8. So we can see that the log of 4.8 times 10 to the negative 8 is negative 7.3187, and so on and so on. So this would be negative 7.32. And then remember, the opposite of that, that negative in front of it, is the opposite of negative 7.3. So that would give me 7.3. Don't use this 10 to the x. We'll use that later. But when we were typing it in, we need it to be in this exponent button down here. Okay, so going back, actually, since we were just looking at this blood calculation, I noticed that I started with 2 significant figures, and for some reason I had 3. So I really should have 7.3 as my pH and 6.7 as my pOH. Sorry about that. Okay, so now let's look at milk. Milk has a pH of 6. What is the concentration of hydrogen ion in milk? And what is the pOH? Well, first, finding the pOH is similar to what we just did right here. We know that pH plus pOH equals 14. So, since I know that my pH is 6 plus what is 14, so we know that I'm going to do I got to get this by itself, so I'm going to do the opposite. So I'm going to subtract 6 from both sides. So we know the pOH is 8. Now, over here, finding the concentration, if I know the pH, is a little bit trickier. We're going to use, obviously, this is what we would need to find, right? We know that pH is equal to the opposite log of the concentration of H3O. So, cleared off some space here. So if I know that the pH I need to work backwards. Now, similar to what we've done before to work backwards, let's say to find something from this equation, we're going to do the same thing for this. Now, let's work and let's get rid of this negative. So I'm going to multiply by each side by this negative. So I can then say, okay, negative pH is equal to the log of H3O plus. Okay, hopefully you're with me so far. Then I got to get rid of that log. Just like if I was to get rid of addition, I have to do the opposite, which is subtraction. If I'm going to get rid of multiplication, then I have to do the opposite, which is division. So to get rid of a log, the opposite of log, and I don't expect you to know this, but the opposite of log is 10 to the caret. So I'm going to multiply each side by 10 to the caret. And that crosses off log. So then I'm left with my hydronium concentration is equal to 10 to the negative pH. And I'm not going to expect you to know how to get to this. Hopefully you can see how we got to it, but now we can write this down in my kind of arsenal of these, my equations, that to find the concentration of hydronium, I would take 10 to the negative pH. So here, to find the concentration, all I need to do is do 10 to the negative 6. And let's look at our calculator to see what we get. Okay, so here's our calculator. And remember that button that I just told you don't touch when we're doing scientific notation? Well, now we're going to use it. So when I want to say 10, so see, it didn't put in that 1 times 10 or 4.8 times 10 to the whatever. It just gives me 10 to the, and I'm going to type in negative 6. And notice that it gives me my answer is 0.000001. And that's my concentration. So 0.000001 molarity, or we could say 1 times 10 to the negative 6. All right, so I wrote this down. The concentration of 10 to the power of negative 6 would be this. Now let's do another example. And so what if I had a pH of 4.76? And so we worked out that problem where we said the concentration of H3O plus would be equal to 10 to the power of the negative pH. So we are going to plug in 10 to the negative 4.76. So when we look at that, we're just going to type in this 10 to the x to the negative 4.76. And we can see that we would get 0.1234017. And that would be what we would write down. 0.1234174 molarity would be our concentration. We could also write this in scientific notation, of course, as 1.74 times 10 to the negative 12345 molarity. And again, this is my hydronium ion concentration.